Awesome. Hello, everyone, and welcome to the Modular Layers panel of the Multi-Chain Infrastructure Summit from LongHash Ventures. My name is Pranav, and today I have with me three esteemed guests from the industry. We have Adelyn from Chainlink, Nick from Celestia, and Shumo from Manta Network and POX Labs. Thank you, everyone, for taking the time to be here. Now, before we begin, I want to just set some quick context for the broader audience on the modular layers and how they're different from monolithic blockchains. So monolithic blockchains perform three main functions: consensus, data availability, and execution. But having one network perform all of these functions is quite limiting and comes with major trade-offs, as we've seen with Ethereum, where transaction costs are high, limiting scalability, and with Solana, with validated requirements being high, limiting decentralization. Now, being able to optimize for decentralization, scalability, and security is what has been coined the blockchain trilemma, and this is something that modular layers aim to solve. Now, while monolithic blockchains perform all these functions in one place in a generalized fashion, modularized components separate these layers. They're built to house a single component of a monolithic blockchain, such as Celestia, which handles data availability, or Chainlink, which is like an oracle, which for real-world price feeds and data sets not available on chain, and Manta Network and P0x Labs that keep your default transparent transactions private and secure. Now, modularity will be key to addressing this blockchain trilemma and bringing about a multi-chain future that is secure, scalable, and decentralized. Now, with that, let's jump into the introductions and would love to hear from each of you about your role and the project and some real-world examples of the problems that you guys are solving. Maybe we can start with Adelyn.
Great. Hello, everyone. I'm Adelyn. I'm from Chainlink Labs, and we support the building of Chainlink. Chainlink is, as Pranav mentioned, Oracle. And what we do is we connect blockchains with data sets, APIs, and even other blockchains that aren't inherently able to communicate with the core blockchain. So I think we're on a dozen plus blockchains, and we have multiple products such as price feeds, which are really popular with DeFi. We have randomness, which are very popular with gaming and NFTs. We have automation that's becoming very interesting as projects want to decentralize more and more part of their stack. And then we also are launching a cross-chain protocol called CCIP, which I'm sure we'll talk about more, especially given the light of this topic. And then within Chainlink, I mean, what we do, I would like to say, form one of the backbones of a lot of the blockchain projects here that you probably are familiar with. I would say a majority of the DeFi projects out there use Chainlink in the backend to help manage let's say their lending and borrowing collateralization ratios, because you need to know the price of a certain asset. Different NFTs use us when they're doing, let's say, fair distributions of their NFTs using our randomness to make sure that the projects are given randomly instead of to, let's say, everybody's friends. And so those are just two simple examples of where we're bringing off-chain data onto on-chain to make applications more secure, decentralized, and reliable.
Got it. Thank you so much, Adelyn. Really nice to see how oracles are being used. Maybe we can move on to Shumo. You can introduce Manta and P0x.
Thank you so much, and super glad to be here. I'm Shumo. I'm the co-founder of Manta Network, and also the developing company behind Manta Network, P0x Labs. So for Manta Network, we're building privacy using the buzzword privacy modular execution layer on Polkadot, and we're building Manta as a parachain. And you might say, hey, like, what is privacy? What is ZKP? At the end of the day, we're basically building a kind of a shield to guard your privacy for various different kind of applications. So thanks to our strong cryptographic team, we are building a very, very versatile privacy preserving prototypes. And you probably heard of Zcash, and you probably heard of the Tornado Cash, and we're building a more general privacy execution layer. So for example, our protocols support both fungible tokens and NFTs. Our protocols support not only DeFi applications, sort of like Aztec style DeFi applications. We also support, for example, anonymous social and anonymous DAO tooling. I think privacy actually are getting into more and more actual Web3 product, and we're glad to be part of the wave here.
Awesome. Thank you so much, Shumo. Yes, I totally agree with privacy being very important in this space. Nick, over to you.
Hey, everybody. Pleasure to be here. I'm Nick White. I'm COO of Celestia Labs. And we're building Celestia, which is the first modular blockchain network. So we've kind of been at the center of this movement of modularizing the blockchain stack, where the core insight is that monolithic blockchains try to do everything at once. And actually, you can, if you go back to blockchain first principles, you realize that you can have a consensus and data availability layer, and then you can run execution layers on top of it as separate blockchains. And it solves, when you take that approach, it solves a lot of the core problems of blockchain infrastructure. Number one being scalability, because all of a sudden you can have a network where the more nodes there are in the network, the more throughput you can have. And it also solves a lot of problems around flexibility. So you're no longer locked into a single execution environment like the EVM or the Solana VM. You can run any kind of execution you want, and you can have trust minimized bridging. So it kind of, we see the modular blockchain movement as this next generation of blockchain infrastructure that's going to, we think, truly enable for the first time mass adoption of the technology, both because it brings down costs for users as well as opens up a whole new design paradigm for blockchain developers. And so Celestia is a consensus and data availability layer that sort of forms like that the base security on which people can run their own execution layers on top.
Got it. Thank you so much, Nick, for introducing Celestia and the data availability layer that you guys are building. Thanks everyone for the introductions and more about your project. I'd love to move on to a more generic question about how you guys are going about interfacing with actual blockchains, and why did you guys select this route, and what advantages do you see? Right, I know that Manta is at least aiming to be their own chain with Calamari live. Chainlink is of course more smart contract nodes driven. It's again moving to more on the modular side, and Celestia is more of like a unique layer one, I guess we can call it, which is mainly ordering transactions and verifying them. So you guys are all taking somewhat different approaches. So I'd love to understand more about how you guys are taking that approach and how you feel that's what advantages do you see? Maybe we can start with Nick.
Sure. So the advantages, I touched on them a little bit earlier, but one of the problems if you're building a monolithic blockchain is that every time, so like the security model of all blockchains is that users verify the chain themselves, because the whole point is that blockchain provides decentralized trust. But if you are not verifying yourself, you're trusting someone else that they're following the rules and they're doing things honestly. So verification is really at the core of blockchains. The problem is that in a monolithic blockchain, when you every node needs to verify every new block. And then if you increase the number of transactions in the blocks, it means that users or people trying to verify the blockchain have to do more work. And so that's kind of like the root of the trilemma that you mentioned, the blockchain scaling trilemma. And what's interesting is that modular blockchains are the first approach that truly solves this and makes it so that you can verify more transactions without actually having to do more work when you're running your node. And the two technologies that enable this are data availability sampling, which means that instead of having to download a full block of transactions, I can just download a very small subset of the block, and validity proofs. So those are fraud or zero knowledge proofs, and they allow me to verify that the transactions included in that block are all valid. So the combination of those two things are really powerful, because it means that I can actually verify a massive blockchain with millions of transactions using something like a smartphone. And the reason that you need to take a modular approach to enable this is that you want to build a very specialized layer that just focuses on the data availability piece, and then you want to build these separate execution layers that focus on the fraud and validity proofs side of things. So by decoupling those two things is how you actually get scalability. Whereas in a monolithic blockchain, you're trying to do both of them at once, and it kind of locks you into this rigid framework from which you're stuck with those trade-offs. So modularity is very important because it breaks you free from the trade-offs of a monolithic blockchain.
Got it. And using that data sampling and fraud proofs is the way you guys are going about interfacing with blockchains and being able to solve that scalability issue.
Yeah. So specifically, Celestia does the data availability sampling part, and then rollups, like developers who build on top of Celestia, use whatever kind of rollup technology, whether it's optimistic rollups or zero knowledge rollups, to have verifiable execution.
Got it. Understood. Thank you so much, Nick. Shumo, sorry.
Yeah, sure. I think this is I think Nick just gave a great answer here. For us, it's actually very, very simple, right? So we choose to build on Polkadot, which is a framework to allow you to write blockchains without managing your own security. And there is a design principle behind that, which is a separation between the security guarantee and also actually the blockchain application logic, right? I think in about 3 years ago, like Gavin Wood himself actually did a very interesting demo. He basically using the substrate blockchain framework, writing a Bitcoin like a blockchain in 40 minutes, right? You don't hear me wrong, it's 40 minutes, right? So essentially, it's very powerful that all the parachains, they only need to care about the blockchain execution logic and also availability of the blocks rather than the security, because the security is guaranteed by the relay chain, which is Polkadot, and have kind of an economy of scale and have a very high both social and economy security, right? So then we can focus on execution logic part. And also, it happens to the things we want to build here, which is a private execution, which requires zero-knowledge proof verifier. And you guys probably know the zero-knowledge proof verification actually is very computational intensive, right? Despite, right, the verification cost of a single zero-knowledge proof is kind of a constant, but this is a big constant, right? So for example, a single zero-knowledge proof takes about 5 milliseconds to verify in an x86 machine, right? We need a high-performance blockchain execution engine, and it happens that Substrate is a very, very powerful engine to allow us to build like customized ZKP execution logic in the Substrate as a powerful thing, so that we can provide kind of like both ZKP and also in general privacy as a service to other parachains. And last but not least, right, a very unique mechanisms in Polkadot I actually didn't see any other blockchain have is that there is an interoperability programming language called XCM. Basically allows parachains to freely interoperable, and you can think of this is kind of like an RPC calls or a smart contract calls other parachains. For example, we're working together with Moonbeam, right? We can directly privatize the Moonbeam's ERC20 asset just purely using the XCM as interface. And this is actually quite unique and very different from all the other mechanism in the market right now. So for example, you might say, hey, there's a Cosmos, there's IBC, but the problem here is that the IBC's security guarantees relies on the consensus of the two chains on both ends. And for XCM, the security guarantees only requires on relay chain, for example, right? So this is actually a stronger security guarantee you can have, right? So based on these three things, right? So I think we're very happy to join the Polkadot family to actually bring the privacy to all the parachain project here. And also, I just want to say, as there are more and more parachains, the privacy use cases will be grow as the network grows as well, right? So that's basically from my perspective here.
Yeah, seeing more and more parachains come every week now. So definitely seeing the ecosystem growing as well. So you guys are basically going to be having your own chain, but relying on the overall security that Polkadot provides.
Right, like everyone else. And also we rely on the XCM, kind of provided by relay chain. And also it's also like you can think of the XCM as the first of its kind of trustless bridge between different blockchains. So that I mean, the only trust you need to put on the XCM messages is basically the security of the relay chain. So it kind of automatically interoperable with, for example, very, very nice players like Moonbeam, like Interlay BTC, and also, for example, like Akala and Astar, for example.
Got it. Awesome. Thank you so much, Shumo. Yeah, Adelyn, moving on to you.
Yeah. On the Chainlink side, we are not a blockchain. That's always been the first thing we've since the beginning. I mean, I think we partner with all the blockchains. So in a way, by not having a blockchain, we're not competitive. We are friends and partners of all the blockchains out there. And to that point, because of that, we integrate and with all these chains, regardless of what platform they're on. So Shumo mentioned Moonbeam. We work very closely with them, and Chainlink is live on that platform, as well as various EVM chains, Cosmos chains, Solana, and different networks. And so for us, on our point, I mean, we have our data providers who then provide information and data to the node operator, who then through our coordinator system, we aggregate that data and find out, depending what kind of data it is, and then push that data on chain. And again, that push into whatever chain, it doesn't matter for us. And as we're seeing more, you mentioned more and more parachains, we're also seeing more and more app chains, subnets, supernets. It is really becoming a very, very multi-chain world. And so through the model that we have, it doesn't matter what chain you're on, what language you are using, what framework, we just port our system into the various ones and put those that data into the various chains.
Got it. So it sounds like more app chains and more parachains, the more friends you guys have.
Yeah.
Awesome. Yeah, thank you so much, Adelyn. I think we want to move on to, just bringing up the point that, we're seeing more and more chains come up. And within this, multi-chain future, as you guys are more modularized chains or modularized applications, it gets harder and harder to actually, capture value because it's not under the same monolithic blockchain. So I want to step back a little bit to understand more about what's the business model look like for you guys? How is the value captured? Does it come, maybe through tokens or maybe some other methods? Would love to sort of get your thoughts there. Shumo, do you want to step in, talk about maybe Manta and P0x?
Sure. I think as P0x is developing labs behind Manta network. And from Manta, right, so basically we are a parachain and we are going to have our own tokens. I don't think token is a value capture mechanism. To me, it's more like a value distribution mechanisms. And because we are using our native token as a gas fee tokens for all the private and also non-private transactions, right? I think for all the app chains and all the public blockchains, I guess the number one revenue model is kind of like actual usage, which is gas fee burns. And that after the gas fee burns, you get some like a scarcity of the tokens, and then you capture the value through the token appreciation by the gas fee burns, right? So I think that's the first kind of first kind of token capture. Right. So also for the privatization, right? So I think the token economy model for Manta is that we won't charge you a token when you privatize. The reason is that we want to attract you to this privacy world, but we will charge a percentage fees. I mean, initially, I think in the first 2 years we won't, but after that we will charge the unprivatized or to public fees, so that's also part of the revenue. I think basically our thesis here is that because Manta is a very, very versatile primitive, so you can do like a FTs, kind of like ERC20, but also substrate token standard. You can do NFTs, and you can even do soulbound tokens, and also you can have various privacy preserving applications like a private social, anonymous social. I think this is going to be a very, very cool feature for us. And then you get more usage, and because you have this privacy default, we want to encourage you to stay there, right? So building this kind of anonymous world together. So we kind of will not charge you fees for privatization, but will charge you fees goes back to public. So this is basically the token economy and like a model. Of course, we still have a little bit of staking. The staking it's a very interesting topic. I wouldn't talk too long, but in high level, for parachain, you still need correlators, which is node runners. Despite it doesn't in charge of security, it's still in charge of availability, right? So for example, you do want to say, hey, you have a sufficiently decentralized correlator runners so that, for example, at least give you high availability guarantees, something like AWS level, right? So then we still incentivize node runners by having parachain staking, right? The parachain staking for us have already been not launched, right? So I guess that's kind of like a three perspective of how the monetary model of Manta, yeah.
Got it. Thank you, Shumo. So it does sound like you guys are incentivizing people to actually, use the private transaction and create this private world. So it's nice how you guys are not charging for actually moving to the private side of things and only charging once it's already in there, like you would in any normal non-private transaction as well.
Yeah.
Awesome. Thank you so much, Shumo. Adelyn, do you want to go next?
Yeah, on our end, Chainlink, the users of Chainlink, mostly these decentralized applications, pay for Chainlink node services and for the data or API or whatever information that they need to bring on. So they pay in the Link token, which is a utility token for these services. And then we do also have staking as well that is coming out in a week, which is much long awaited. So exciting times there. And so for us, the value of Pearl is really users and usage. And as you say, we're over almost 2,000 applications who are paying for Chainlink services for that. It's as simple as that.
Got it. Yeah. Do you want to touch a little bit more on the staking side of it since it's coming out in a week?
Oh yeah, December 6th, I think, early access. So I think people, first time, it's been long awaited. The team has been working really hard, again, to make sure that it's secure. We're not a blockchain. We're not the same as everything else. So how do you use the staking to provide additional security guarantees for the nodes that are pulling data and information into the blockchain? So the staking, you get rewards from staking because you're providing additional security, kind of similar to any other system. But we'll be sharing even more information on the 6th of December.
Okay, got it. Yeah, we'll keep a lookout for that. Thanks, Adelyn. Nick, do you want to go next?
Sure, yeah, I'll go next. Well, I just want to congratulate Adelyn and Chainlink on the upcoming launch of staking. That's awesome. So congrats. So for Celestia, in terms of value capture or value distribution, however you want to call it, the use of the token is essentially that we run a proof of stake network. So the proof of stake is sort of a Sybil resistant mechanism that allows us to actually come to consensus and secure the chain. And on top of that, people will use the token to basically buy block space on the Celestia ledger. And so essentially, like, Celestia is in the market for raw block space. And block space is sort of this, it's not quite a commodity because each chain has different, like block space across different chains has different properties. But block space is sort of like the ability to write data to a public immutable ledger like Celestia. And when you write data onto a ledger like that, you can actually then run applications and do all kinds of decentralized applications. So like block space is this primitive that the whole space is kind of built on. And we think that long-term, the demand for block space will grow exponentially with the adoption of blockchain technology. And so kind of one of our goals is to bring the cost of block space down dramatically, kind of in the same way that the cost to store data or to run computations has dropped dramatically throughout the last few decades because of all the advances in hardware, like computer hardware. So that's kind of the thing. And so the more people that are paying to write data to the Celestia ledger, then the more I guess of the tokens will be spent on these transactions. And we plan to implement some kind of fee burning mechanism eventually, like EIP 1559. So the more demand for the token, then the more that token is consumed.
Got it. And just to understand a little bit more on this block space side, if I'm an application that needs to use it and want to buy some block space from you guys, is it something that I will buy more like a just-in-time thing, or can I buy in advance since I know that I'm going to be using it if I'm a more sort of popular application?
That's a really good question. For at least within the base layer itself, you will pay for the transaction that you submit. So you will submit what we call a pay for data transaction, where you will have a certain amount of data that you want to write to the ledger, and then you will say, I'm willing to pay this much. And there's basically a fee market essentially to allocate block space to people who are demanding it. Now, I think there could be possibly someone building some kind of like block space futures market, or I don't know how it would work, but that's something that I could see being built in the long term. And the interesting thing too about Celestia versus other blockchains is like, blockchains typically like Ethereum, for example, when they get adopted, there's more and more demand for block space because there's network effects naturally around a blockchain, because the more applications, the more users there are in one network, the more useful it is for each marginal user. But then the problem is that in a monolithic blockchain, you have a finite amount of space. There's a finite number of transactions in every block, a finite amount of data. And so you end up with this negative network effect when you saturate the blocks, because it gets more and more expensive for each marginal user. So then you kind of reach this like feedback point where it's like the utility of the network and the cost to use the network kind of balance each other out, and they prevent it from growing more. And that's why, people have left Ethereum for other cheaper blockchains. Now, the cool thing is that in a modular blockchain like Celestia, the block space is not finite and actually can grow. The capacity can grow with the number of nodes in the network. So you can have more and more users join, while keeping the cost constant, so you don't end up with that negative feedback loop, which I think is going to be really powerful once it's live and things are working.
Awesome. Yeah, thank you so much for that, Nick. So you guys are all building really cool things, and it's amazing to see the progress that has been made. I want to step a little bit into the competition side. You guys are all entering markets and already in markets that are super popular, and there are other projects that are trying to do the same. I want to understand a little bit more about where you see probably the biggest competition and how you guys plan to stand out. So maybe we can start with Adelyn. Maybe I think the only other bigger sort of fundamentally different approach would be Pith, and maybe a few others. Would love to see if you can touch up on that and provide some context.
Yeah, I think for us, our biggest competition is ourselves. I think we created this space, helped popularize what oracles are, and have become the standard that all the projects who demand security and all the different chains are using. I think for us, it's really just how do we keep ahead and continue to iterate and to make sure that we are innovating throughout and that we don't rest on our laurels. I think for some other alternatives that do pop up, I think they might go to some chains that we haven't been on as early, since we are focused on continuing to growing out of the product suite that we have on this existing chain. So I think that's where we might see some, but for us it's really just we have I would say the market leading product. Everyone it's the most secure, most reliable, like there's no question about that. And so for us it's really just making sure that we continue to deliver and that we get onto chains faster, move, and continue to grow out the product suite.
Yeah, you guys are quite OG that way, so totally get that. Shumo, do you want to go next? Maybe talk about the other projects in the space, especially the bigger ones, I guess, the Secret Network and the Aztecs of the world.
Right. I think that's a very, very good question. First, I think, first, in my view, I think the entire ZKP and privacy space is very, very early. And honestly, we don't view them as competitors, especially Aztec, because we're using very similar approach. And Aztec has amazing cryptographic teams and create a wonderful technology like Plunk, right? We might even adopt that in the future. But it's more about like how can we make privacy as a default? How can we get a ZKP application adoptions to the entire space? How can we make some more and more people using this like privacy by default decentralized applications? And I guess maybe my angle is a little bit different here, right? So for example, our thesis is that we should build good product. We should make the privacy transaction cheap so that people are just like willing to do that, because there is a natural kind of adoption curve here, right? So for example, the cheaper and the better you can make your product is, and there is going to be more adoption, right? So that's the first place. And in terms of a comparison, right? So for example, for us, I think there are two kind of projects, privacy project on the market. And one is like us, like Aztec, like Zcash, like Aleo. We're using ZKP as a fundamental technology to protect users' privacy. And also there is, for example, Oasis and also like Secret Network. They're using TEE or Trusted Execution Environment. And more specifically, most people are using a very special kind of TEE, which is Intel SGX. I think fundamentally, I think I definitely have more like faith, and I think zero knowledge proof is the only way makes sense moving forward in the next 20 years. The reason is very simple, right? I think TEE is a very good technology, right? But the problem here is that I just want to claim here, I used to do some TEE research, right? I myself published a paper in a top-tier journal like called VLDB on the TEE confidential database. The problem with TEE is that it's a very, very complicated hardware primitives that sitting on Intel chips, right? I think it's fine to do the enterprise computation. It's fine to use the cloud computing. But if you want to use in the decentralized network, essentially how does the confidentiality in the TEE guaranteed is that every single validators, they have their own TEE, and every single confidential information have to be in each single validated TEE. So this has brought up a problem here, right? TEE actually known for vulnerable to side channel attacks, right? Because TEE, the memory access pattern of the TEE actually leak a lot of information. So there are numerous papers about that. I wouldn't bore you on a specific paper. The problem here, you can see there is a asymmetry, and also there is a inherent confliction between decentralization and confidentiality. Normally, you want the technology to be confidential. You want to minimize the attack surface here, right? For ZKP, the attack surface is a mess, right? It's really about mathematics. And unless you can crack some like a P equal to NP or having some like a magic quantum computer, and your secret is safe, right? And for TE, right, because it has a lot of side channel, the more decentralized node runner you have, the more vulnerability like your secret have, right? So this is there is basically an inherent confliction between decentralization and also the confidentiality, right? I'm not saying people are going to crack Oasis or like a secret network tomorrow. We just see there is an inherent confliction in the security design here, right? This is the approach we want to take, a more principled approach, right? So moving forward, right? So basically that's my view. Yeah.
Got it. Thank you. Thank you for touching on that and the different tech that goes behind it. I want to, if you don't mind, just ask you one more question. What are your thoughts on the more homomorphic encryptions that are coming up more into the privacy space now? How do you see them competing with the existing solutions that are being used?
So when you're talking about homomorphic encryption, I think we need to be a little bit more precise here. There is a partially homomorphic encryption. For example, like we're actually using partially homomorphic encryption in part of the protocol, right? So for example, some encryption scheme like Agamo, and there is a fully homomorphic encryption. I think I do think like FHE is a very, very important technology in the next 20 years. I think the problem right now is that fully homomorphic encryption actually can extend the blockchain use cases. Let me give you one specific example, right? So ZKP is basically private execution. But what ZKP cannot do is sort of kind of like a secret distribution scheme, right? For example, you have your private information and you have a private execution, you prove it using ZKP, right? And then you get another private result. So let's say there are some limitations with ZKP. For example, if you want to do a first price Dutch auction, right? So you have to using ZKP plus FHE or some sort of MPC to do the scheme, right? I think it's very, very powerful, and I think I hope we can get more and more in like a technical advancement in fully homomorphic encryption in the next 20 years. But the problem right now here is that it's inherently very, very slow, right? So, and also I think there are some technical details here, but currently the most widely adopted fully homomorphic encryption scheme called CKKS. It's an approximate scheme. It's good for machine learning, but if you want blockchain you actually want to deterministize result, it's not really suitable. And now all the precise homomorphic encryption scheme is very, very slow. I think it's about 6 orders of magnitude slower. And you basically add the penalty of the ZKP and then add the penalty of a homomorphic encryption. It's just like it's not quite practical yet. But I do hope we work hard on the technology side to bring the homomorphic encryption into the blockchain space in the next 10 to 20 years.
Got it. Yeah, the speed, I guess, is why you're giving the 10 to 20 year time horizon. Hopefully the tech catches up before then. Thank you so much, Shumo. Super helpful. Nick, do you want to dive into some competitors and how you guys are coming out as a winner?
Yeah, sure, of course. So Celestia was actually the first data availability network. The project started in 2019, kind of before data availability was a category. And today it's the only one with a live testnet with data availability sampling and block reconstruction implemented, which is sort of like those are the two core features that you need to have a truly secure data availability layer. And we've been on testnet for over a year, and we're ramping up to incentivized testnet and launching in 2023. So I think we are probably the most technologically mature and furthest along in our engineering roadmap of any other data availability layer at the moment. And so, but it's been great to actually to see the growth of the data availability category, because it really kind of strengthens that this is the the direction that blockchains are going to move in going forward. And specifically, what's been really cool is the adoption of this sort of rollup centric, data availability centric roadmap of Ethereum. And over time, the Ethereum community has sort of pivoted away from what they called execution sharding, which was like you have a bunch of sharded chains off of the beacon chain to they started doing data availability shards, and then they pretty much pivoted to a design that is very analogous to what Celestia is doing. So we see that as a really strong validation that the design that we started with for the beginning is really like the right one, the end game, so to speak. The thing about at least Ethereum's data availability roadmap is that they have some limitations and also just a bit of a different philosophy. So they started with this monolithic layer 1, which is the Ethereum chain that we know today, and they can't. If you want to go fully modular, you have to actually remove all of the execution from the L1, but they can't do that because they already have all those applications and users and value on that chain. And so their hands are a little bit tied there. And so they're adding this data availability part kind of on the side in addition. And there's pros and cons to that. The pro is that they have what you call built-in settlement. So rollups that want to settle back to Ethereum have this execution environment that they can do that to. But the downside is that you have all this extra baggage and weight, and the chain is not fully modular and incurs more overhead for rollup developers. So, and also it kind of it's just philosophically different. Like we think of rollups as independent blockchains in their own right, kind of more like Cosmos zones. And I think Ethereum thinks of them rollups more as like baby chains that are meant to scale the Ethereum base layer. But we think that's a really short-sighted way to think about what rollups are. So that's at least Ethereum. There's some other, Avail is also coming up. I haven't actually kept track on the status of the development. They are using KZG commitments, which are slightly different sampling scheme, but we think is not really mature. And then there's EigenDA, where it's really cool because they're taking a different approach to providing data availability, but fundamentally has really, really strong security trade-offs. So EigenDA is actually trusted in the sense that the whole point of data availability is that you don't have to rely on an honest majority, but in EigenDA, it's more like Plasma. Like you can't actually, there's no data availability sampling. And so you can't know that the data is there. You have to trust the signatures of a group of validators. And so fundamentally, it's like just less secure and can't actually, like if you're using EigenDA, it's not really a rollup. It's more of like a Plasma or Validium. But that some people might want to use that. It's a different set of trade-offs. If you have a less, maybe you don't care so much about security and you want something that's really cheap. I'm not actually sure that it'd be that much cheaper either. It all depends on when things are in production. There's a lot. That's the struggle right now with the data availability landscape is that very few projects are actually in production or close to production. So it's hard to. There's a lot of claims, but it's very hard to actually compare apples to apples until things are live and built.
That's true. Yeah,
I agree with what Nick said too. A lot of times people if you have a white paper, you can claim the world, right?
Yeah.
Until you actually start building, that's when you realize the rubber hits the road. Like the TPS claims or whatever claims are not quite what you expect them to be. So you want a battle tested, a proven, as Nick said, theirs has been on testnet for a long time. Ours has been in production for a long time. That's where the real metrics come out.
Yeah. That's so
yeah,
true.
I can definitely attest that. Like we have been testnet through March. This is our third version of the testnet. Numerous engineering efforts, just putting in every single details, including security, speed, UI, UX, developer experiences. Yeah, just it's production is much harder than white paper for sure.
Yeah, all the trade-offs will only be trade-offs when you're actually live and functional. Awesome. Thanks a lot, guys, for that. I want to just give each of you guys a few minutes to talk about the grand vision of the project. Now, I know that where each project is currently is a subset of where you guys actually want to be, and obviously we're still very early in the space. Like we just spoke to on the data availability side, most of the projects aren't even live, and so we're all in this very evolving state, and we all have different end visions than where we are today. So I would love to sort of give each of you a few minutes to talk about that. So maybe Adelyn, you guys can talk about 2.0 and CCIP. Shumo, you can talk about how P0x is going to come in and what's the next step for Manta. I know Celestia, Nick, you guys want to basically become this interoperability layer. I know this is like grand visions, and I would love to give you guys a few minutes to talk about that as well. So you maybe Adelyn, you want to start off?
All right, great. So on our end, thank you for teeing us off. For us, we started as oracles and about connecting on-chain and off-chain, right? It's all about the connectivity of a blockchain and everything else. And that off-chain could be another blockchain, right? On another blockchain, or it can be data or systems or anything else that's not inherently there. So for us, one of the big things that are upcoming is CCIP, which is our cross-chain protocol. As we all know, cross-chain is one of the hardest problems to solve because of the security around it, and it becomes a target for everybody, right? Because of all the value that's in it. But it's also one of the most critical things that we need to solve, as you have all these projects going multi-chain. You have, their governance on multi-chain. Like, if we want the blockchain, space to truly move forward, we have to live in this cross-chain, multi-chain world. And so we've been working on this product to allow the cross-chain transfers of valued assets using what we call OCR 2.0, which is our core base for a lot of our oracles. And we've have experience of securing almost over I think there's been over what we call TVE, total value extracted of enabled of value on the blockchain of over $6 trillion. And so we've had that experience and leveraging years of securing all that money to put that into our CCIP protocol. And so that's where I would say a lot of our engineering efforts and time has been spent. And then on top of that, right, once you have CCIP, there's tons and tons of enterprises who are really, really excited about this. I mean, we have a proof of concept with Swift, that one of the largest financial intermediaries, on using this system like CCIP to do transfers of data and also financial information. And so for us, there's lots of enterprises who are excited about it. And so once CCIP is around, a lot of more enterprise adoption will come around, and which we are excited because that will enable more blockchains to be actually truly useful in the financial systems, right, that we actually use in our day-to-day, and not just tied to DeFi in this tiny part of this massive world. And so I would just say overall, Chainlink, what we're doing is taking our existing experience that we've had battle tested for years, securing tons and tons of value, and using that experience to connect. So connect blockchains, connect data, connect off-chain systems, connect enterprises with the blockchains that we need. So that's where we are going.
Awesome. Looking forward to that coming live and getting this whole new wave of adoption entering the space. It's awesome. Nick, do you want to go next?
Yeah, sure. So Celestia's vision, there's many different parts of it. So I'll maybe start on the technological layer. So the technical vision is that we want to build modular blockchain infrastructure that solves the key problems with blockchains, namely scalability, decentralization, and security, and makes it possible for anyone to deploy a new blockchain kind of at will, and to plug into this security network that Celestia provides. So in the sort of the follow-on higher level vision is that we believe it should be as easy to build a blockchain as it is right now to build a website. So now, as Web 2 matured and cloud technology became a thing, it made it possible for any developer, wherever they were, to just go to AWS or go to Azure or DigitalOcean and deploy a server for their web app or their website. And we think that blockchains Web3 needs to reach a similar level of maturity of infrastructure for us to really hit mass adoption. And so Celestia, in that metaphor, is sort of the data center that has this infrastructure as a service that any Web3 developer can come to and say, I'm going to deploy this blockchain with this sort of configuration, this execution environment, et cetera. And so and then the higher level vision is that blockchains are, this is the social vision. Blockchains are, decentralized trust networks. They're social coordination mechanisms, and they're meant to be, they're going to be a very fundamental tool for sort of building the next sort of, I would say, platform of human collaboration in the 21st century. So I think, people are going to be building the equivalent of governments or corporations and all these new kinds of shared applications. And Celestia wants to sort of be the underpinning infrastructure behind all that and enable the growth of sovereign communities around the world via blockchain.
Awesome. Thank you so much for that, Nick. Exciting to see all of that come to fruition. Shumo, do you want to go next?
Oh yeah, I think before we talk about the vision, right? Let's look at where we are right now, right? If you look at any popular blockchain platform, I would say all the ZKP-based transaction or privacy-based transaction will take less than probably 0.1%, right? So which means we have a huge space to grow, and this is basically our mission. And if you look at, let's say, where does this space go, right? I don't think this space will be all private transactions, right? Because the point of blockchain, we need certain kind of private transparency, right? In a lot of governance cases, you want certain degree of transparency, but also we definitely need way more than like a 0.1% of the ZKP or privacy-based transactions, because privacy is a core value of the decentralization, right? What does it mean to be decentralized? Basically, we want to leaving is kind of like anonymous word, so that what really matters is your merit. What really matters is what you did, rather than like which institution you graduate from, which every league schools you get your PhDs, right? This is we want to moving to this anonymous world. And with that said, right? So I think basically we want to find a way to moving forward, and more specifically, we think basically in the next 5 to 10 years. And the privacy, we want to building strong product that privacy is not just for privacy, it's actually making the product better. And we identify a few key areas can make this happen. Let me just name a few here, right? And first, of course, is private DeFi, right? Because financial privacy is every single people care, and you don't want to disclose your bank account and bank transactions on the blockchain, and maybe even your grandparent, your like grandchild will see, hey, like my grandpa or grandma just did this one day, did a single transaction. That's what we stay there forever, right? And that's obvious. And also, I think like a DAO tooling is somewhere we really actually starting to working on. Basically, you want to have a decentralized governance, which is have anonymous, right? So the democratic system build this like anonymous voting for a reason, right? Because we actually see a few cases, a few projects, they have certain level of voter retaliation, and you have some linkage of the cryptographic addresses and your real world identity. Then the people have a huge conflict of interest during the voting. And also, which makes our super exciting, is basically anonymous social and also like a ZK-based gaming, right? So for anonymous social, right? So basically, we want to having this kind of anonymous social environment, so that you can say something, but without worry about retaliation, right? I think this is very important to build a decentralized society. And also for gaming, that's something usually people don't talk about that yet, because people saw that the technology is not mature. I will say yes, but we're getting there. The idea here is that any kind of hidden information game, right? Theoretically speaking, if you want to play on-chain, you need a certain way. For example, let's take a very simple example, like Texas Hold'em's example, right? So like if you want to play Texas Hold'em on-chain, you don't want your competitor see your card in your hand. That's basically MEV, right? So we're actually, from both Manta and P0x Labs, we're actually having a bunch of cool products in the pipeline of launching. So I do want to say this is basically our approach here. And in the future, we think entire blockchain space will be a mixture of privacy and also transparent blockchains. And there are pros and cons. I think privacy is a basic human right, and you should opt in privacy wherever you worry about retaliation, you want to keep your secret state. But the public state is also very important because it brings you composability, right? For example, a lot of cases, I think the future world are going to be, there are several privacy states and will be composed under public state of the blockchain. And that's, I think, that's, in my view, where the future of the entire privacy space is going. Yeah.
Awesome. Thank you so much, Shumo. So from what I'm seeing, the grand vision is, again, obviously to bring in more adoption, whether it's from Chainlink, CCIP, bringing in more enterprises and more financial use cases, to Celestia with actually being able to have any chains data availability done through, make it easy to set up a chain and execution as it is to set up a website, which is a great analogy, and Manta network as well, enabling the ability to have private transactions even in a world of transparency, and having that driving adoption as well. So I know we're off time, so I just want to thank you guys so much for taking the time to do this. It was a super insightful conversation, and very, very excited to see what is to come with the projects ahead. Thank you so much, Shumo, Nick, and Adelyn, for taking the time. It's been a great session, and looking forward to seeing what's yet to come. Right. Thanks a lot, guys.
Thank you, Pranav. Really appreciate it.